All right, so like I was saying, y'all, perfect square, factoring perfect square trinomials. Uh, to be honest with you, you know how this is based on the idea of this is based on the idea. Remember when you have um, a plus b squared, that automatically becomes a squared plus, and then you multiply these together and times and double it times 2. So 2ab plus b squared. Now, all right. And then if you had a minus b squared, all right, that becomes a squared minus 2ab plus b squared. This stays positive because negative b times negative b is a positive b squared. Now, guys, I'm going to go ahead and just shoot you straight, all right? If you didn't memorize this shortcut, then today's lesson's not going to be uber helpful for you. Because like if you expanded this and did it the long way to get your answers, that's fine. Remember, I told you could do that and get the same answer, right? Well, guess what? Today's lesson is the reverse of this shortcut. Okay? It's saying when you see a situation like this, where you can take the square root of this, the first term, and the square root of the last term, and the middle term, are those answers times 2, times each other times 2, it's going to be one of these situations. But if you don't know to look out for that, like if you didn't memorize it the first way, working backwards ain't going to work for you, kind of thing. So the good news is you didn't have to memorize this shortcut to get to those answers to distribute it out, right? You could have said a plus b in parentheses times a plus b in parentheses and distributed or foiled, whichever way you want to think of it, and gotten to these answers right here, okay? So same thing applies with the reverse, okay? If you look at this, the shortcut is supposed to say, like when you look at a problem like this, and then of course always the first thing we do is do any of the three have anything in common. 4x squared, 20x, 25. The 25 takes that out of contention. There's nothing I can take out, right? So after we've done that, now it's telling you can, if you want to, if you notice and you go, oh, 4x squared, I could take the square root of that and get 2x. Oh, 25, I could take the square root of 25 and get 5. Well, if this is 2x and the square root of this is 5, 5 times 2x is 10x, and if I double that, I get 20x. So that's saying that you can automatically say, oh, okay, that's just going to be 2x plus 5 squared. It's the reverse of that other lesson. Now, boys and girls, just like with that other lesson, the good news is if you don't see that, you can do it the old way, where you say, so if you don't see that relationship, okay, you can do it the old way. The old way being, is there anything I can take out? No. Well, A times C, 4 times 25 is 100. I need two numbers that multiply to give me positive 100 and add to give me positive 20. That would be 10 and 10, right? And then I would say, I don't have a lot of room, but I would say 4x squared plus 10x plus 10x plus 25, right? And then on this one, on this set, I would take out a 2x, and that would leave me with 2x plus 5. And then on this one, I would take out a 5, and that would leave me with 2x plus 5. And then once again, my answer would be 2x plus 5 times 2x plus 5. And I just have to be smart enough to know that if I don't see this answer on multiple choice, I need to be smart enough to know that it very well may be written like that. Does everybody see that? So in reality, this lesson is no stress, because it's basically saying, hey, like for me, I look at this and I automatically notice that I've got some perfect square stuff in there. And that's just from doing it for so long. So when I notice that, I'm like, if I take the square root of that, it's 2x. If I take the square root of that, it's 5. 5 times 2x is 10x. And then I would double it. Boom. It's a perfect square problem. Trinomial. Okay. But like I said, if you don't see that, you're still going to get to the right answer. So please, no stressing. Okay. So basically, it's just showing you that you do have these options, that you can take that shortcut. All right. But it's not like you have to do it. Does that make sense? All right. So let's look at another problem. All right. So basically, I covered all of this already. Like, I did this problem, how this is the same thing as this being factored out. I did that on that screen right there. Okay. So the key concept of all of 8-7, this one was the one we did yesterday, where you had two terms, both perfect squares, subtraction sign in the middle. Okay. That is the one that you really have to know. There's no way around that. No cutsies, no backsies. Okay. So this one, you really have to get this concept. All right. These two, like I said, you can do those either way, old school, and you're still going to get there. All right. So this one, we just cheat coded on the other page because apparently I don't know how to wait. But if you look at it and you go, see, nothing I can take out, but I can take the square root of this one and the square root of that one. The square root of 4x squared is 2x. The square root of 25 is 5. And then I multiply them. So that would be 10x, and I double it. I see that I get the middle number. So I can go ahead and say my answer is going to be the 2x plus the 5 squared. Now, the good news is if you choose to do this shortcut, guys, you know you can actually distribute or FOIL this back out to check yourself. So just like on all these lessons, you can check to make sure you got the right answer. Okay? Now, if you look at this one, the next one, I need you to be careful, because if you look, 9y squared, negative 12y, and 4, nothing I can take out in common. But then I glance at it again and say, oh, my first ones and my last ones are perfect squares. I can take a square root, right? So the square root of 9y squared is what? 3y. What's the square root of 4? 2. Okay. Now, guys, this has to be, and on this one, I need it to 2 times 3y is 6y. In double 6y, you get positive 12y, which means that in between this one, I would put a subtraction sign to make it negative 12y. Once again, if you do not see this cheat code, it is okay. You can still get there doing the old-fashioned way, okay? Now, example 3, everybody should be able to do because we did it yesterday. So go ahead and do example 3 for me. Everybody should be able to do, this is the one that you cannot do old-fashioned. You have to do it the way we did yesterday. Okay? Which means you have to look and make sure, it's a subtraction sign, all that jazz. Okay, so hopefully you looked at this and said, oh, I can take the square root of 4x squared, and I can take the square root of 36, and it's got a subtraction in the middle. Let's do this. Now, guys, on this one, yes, you can take out a 2 of both of these. Oh, I could take out a 4, just kidding. I could take out a 4 on both of these. So I could, if I wanted to, pull out a 4 and get x squared minus 9. Then I could take the square root of the x squared and the square root of the 9, and I've still got a minus sign going on. So I'm going to drop it down and put 4, and then the square root of x squared is x, so I'm going to put an x. I know that one's a plus, one's a minus. Remember, it does not matter which is which. And then the square root of 9 is 3. And that would be my final answer. Now, if you, some reason, didn't pull out the 4, I just want to show you what would happen and how you can sort of save yourself, kind of, if that makes sense. So, like, if you were like gung ho about this and got all excited that, 4x squared was a perfect square and 36 is. So, I get that you might have automatically jumped and been like, woohoo! Okay. So, if you would have done that, all right, but remember, the first step is always see if you can pull stuff out. All right. But if, let's say you were like, yes, let's do this. All right. So, you would have done your parentheses, and then that would have been 2x minus 6 and 2x plus 6. Then hopefully you would have realized that both of those aren't, they have a common factor of 2. So to simplify the first parentheses, I would have had to factor out a 2 and gotten x minus 3. And then to simplify the second parentheses, I would have had to pull out a 2 and gotten x plus 3. And remember, all this is multiplication, right? So I can rearrange stuff. So the 2's that I pulled out, I could have put up at the front, because remember, commutative property means I can pretty much move these things wherever I want, if it's all multiplication or addition. But this is multiplication. And then this 2 times 2 would give you that 4. So do you still how, if it were a multiple choice test, do you see how you could still get to see your final answer? Does everybody get that? And if it was a write-in, you would just have to remember, when you have your final parentheses factored out, there should be no commonalities between those things inside a set of parentheses. Okay? All right. So, all right. So if you look at this one, TBH, I would not give you one this hard, but I just want to give you practice with fractions, because I don't want you to be scared of these things when you see things like this, okay? I don't want you to be intimidated by them. I mean, not scared. I know you're not going to run in fear, but I don't want you to be intimidated by things that aren't pretty, okay? So if you looked at this, remember, you would just ask yourself, if you looked on this side, okay, nothing in common to pull out. Can I take the square root of x squared? Yes. The square root of x squared is x. The square root of 1/4, guys, remember what I said. To take the square root of a fraction like that, you just take the square root of the top number and the square root of the bottom number. Okay? So the square root of 1/4 would be 1/2. Everybody get that? Now, does everybody see 1/2 times x is half x? And then if you double it, you get 1x. Does everybody get that? But I really want a negative in here, which means that I would write x minus 1/2 squared equals 0. Okay? Now, guys, I'm going to show you something new. And like I said, I'm not going to, this is super easy, but I want to show you once again, you could do this the old way. All right. But like, because it's equal to 0, if you wanted to, if I bothered to write, like expand this out and say x minus 1/2 times x minus 1/2 equals 0. Do you see how I would get the same answer here? Like x equals positive 1/2. Does everybody get that? Okay. So I'm going to show you why. All right. So I'm going to show you why you would get the same answer on this one. When you have something like this in parentheses with a square, okay, the easiest way to get rid of that square is take the square root of both sides, because we know squares and square roots cancel each other out, all right, which would leave me x minus 1/2. And then remember, what times itself gives you 0? That's just always going to be 0. And then you get one answer of 1/2. Okay? So I really just want you to get into the idea of not being like intimidated by fractions, because so many people are. I mean, I don't like them, but I ain't gonna let them boss me around. Now, so guys, on this one, on these 3 problems, once again, if you have one like this, it would probably be extra credit. I mean, I would warn you ahead of time. All right. But to solve these equations, I want you to look. If you look, and somebody I know for the EOC, I think it was an 8th grader, was asking me about something like this, like they'd already started practicing something like this. So once again, we have a setup right here on this first example where it's something squared. And that is my sign that I am probably going to take the square root of that answer of both sides. Okay? So I need to get rid of that something squared. I need to get rid of that squared. So I'm going to take the square root of both sides. So boys and girls, I would get a plus 4 on this side equals, now this is the part that I want you to be careful about. The square root of 49, everybody thinks, oh, it's 7. And you're not wrong. But the square root of 49 is positive 7 and negative 7. Because negative 7 times negative 7 gives you positive 49. Just like positive 7 and positive 7 gives you positive 49. Okay? So on these answers, you will get 2 numbers like you're supposed to. The only time you don't get 2 numbers is when it's set equal to 0, because there is no negative 0. That's why that is the anomaly where you only get one answer where it's got a square on it. Okay? It's because there is no negative version of 0. So you can only get one thing. But on this one, to solve for this problem, all you would do is you would say a plus 4 equals positive 7 and solve, and a plus 4 equals negative 7 and solve. Okay? And then this would give me a equals 3, and this would give me a equals negative 11. So my solution set would be negative 11 and 3. Okay? Now, just to change it up a minute, just a minute. Trying to make more room. All right. So if I look at this one, all right. So once again, first thing, remember, you just concentrate on one side. And first thing you can do is you can get this into the perfect square. This is a perfect square trinomial. So the square root of y squared is y. The square root of 4 is 2. If I multiply those two together and then double it, I do get 4y. All right. So I know this is going to be one of those perfect square trinomials. And so I'm going to end up writing y minus 2, because that's a negative sign, squared equals 25. Now, once again, to get rid of the square, I need to take the square root. But remember, it's an equation, so what you do to one side, got to keep it equal and do it to the other. So then this square root and this square, battle it out. There's no survivors. And you're left with y minus 2. Now, that's a 2, not a z, sorry. Now, who can tell me what I'm going to have on the other side? Will? Just positive 5? Good job. Positive and negative 5. So guys, instead of writing positive and negative 5, this is that symbol for plus and minus 5. You're saying that the answer is positive 5 and negative 5. Okay? Because the square root of y squared is y. The square root of 4 is 2. Okay? If you do 2 times y and double it, you get 4y. Okay? So now, once again, you set up your two problems. Y minus 2 equals positive 5. Y minus 2 equals negative 5. And you solve. So that would give you y equals 7 and y equals negative 3. And so my solution set would be, oh, Lord, negative 3, 7. I'm really bad at those. All right. Like I said, guys, I'm more interested in exposing you to these problems so that when we do focus more on them, it's not like, you know what I mean? Because I know these take a while to get used to how to do them. So please don't be like, I don't understand. Hello?
Attention, 8th grade teachers, please pardon this interruption. If you have any students with STEM applications, please allow those students to turn those applications in to me at this time in the guidance office. Students with STEM applications, if you have those ready to turn in,
Did your contact fall out?
do so at this time
I'm sorry.
to me in the guidance office. Thank you.
All right.
Where's the guidance office?
Up at the office. You can just ask them. All right. So, guys, this one is a little bit funktastic. I definitely, I'm straight up not giving you one like this. And if the EOC gives you one like this, they're jerkosaurus. But it's not hard. It's just, yeah. All right. So, you're going to do the same thing. Let me change colors. You're going to do the same thing, guys. But sometimes you got to realize that it's really just not pretty. So, I saw this and I'm like, ooh, I want to get rid of that. So, square root. That would give me x minus 3 over here, just like we want. There is no square root of 5, so you would, honest to goodness, leave it plus or minus square root of 5. Okay? And you just leave it like that. So then, and from this point on, you just leave it like that. So it's not like you're doing anything hard. It's just different. You're not used to you know what I mean? You're used to being square roots and getting a number and replacing it. So on this one, you would do the same thing. I just want to show you this. So x minus 3 equals positive square root of 5. And then x minus 3 equals, boys and girls, you have to put the negative outside the square root of 5 or you've made an imaginary number. At this point in your math career, it is okay to have imaginary friends. It is not okay to have an imaginary number. All right? That's a no-no. Imaginary friends we should talk about, though. All right. So your answer, then you're just going to add the 3 to both of them just like you would always. But your answer would be x equals, and remember, square root of 5 plus 3. because you can't combine those. So that would be your answer. Or x equals negative square root of 5 plus 3. So this time my answers look ugly, but those are right. Okay, so once again, it's really about trusting the process. Algebra, once you learn the thing, you do the same thing no matter how pretty the problem is or how ugly the problem is. You just go with it. All right, so my solution set, I'm going to put the negative thing first. Negative square root of 5 plus 3, comma, positive square root of 5 plus 3. Okay, so once again, just want to expose you to these. You're not doing any of the equations today. We'll focus on that later. But I also don't want, because they're completely based off these lessons, I really felt like it'd be a good time to show you how they're related. Okay. Now, so like I said, guys, in review, just to recap, perfect square trinomials, if you do not see the pattern, you can kick it old school and multiply the A times the C, break it down, and do by grouping. You got it. You can do it that way. But look at the pattern and say, okay, I can't pull anything out. Oh, 4x squared, that's a perfect square. Let me go ahead and check the last thing, see if it's a perfect square. If it is, 4x squared, the square root is 2x. Square root of 25 is 5. 5 times 2x is 10, and if I double that, I get 20x. So then that means that those are the two things that make up inside the parentheses. And then same thing down here, except if my number is a negative, I put a minus sign. Okay? So like I said, guys, there should be no pressure on having to get this right because you can always kick it old school. It just saves you a lot of time. If you're lazy like me, it's worth remembering just a little bit more to save time. But that's cool if you're not, because you don't have to be like me. All right. Just be yourself. Everyone else is taken. All right. So we are going to go for it. Challenge. All right. So, guys, I'm gonna need, like, I'm not gonna call anybody out, but you know who you are. I got some of you in here that are doing 1 or 2 problems and being like, oh, I have this. No, you don't. No, you don't. If you did the first problem, that's normally the easiest one I give. You don't have it. Okay? So I'm gonna need you to actually do these problems. All right? I mean, I love you, but let's face it, you know who you are. All right? So, page 543. Thanks, babe. Page 543. I can give you the easier ones of these first. All right. Yeah, I'll give you the easier ones of these first. I do want to show you some. I'm going to do one of these with you. Guys, be careful. You know how we had primes? 6x squared. One of these problems, I'm not going to assign it to you, obviously, because I'm doing it with you, but I feel like I need to do one of these with you. 6x squared plus 30x plus 36. All right. So, I mean, they're all divisible by 3. Everybody gets that, right? They're actually all divisible by 6. Everybody gets that, right? Okay, so I'm going to pull out a 6 out of all of them. So now I've got x squared plus 5x plus 6. Okay? It says on one of these, it's on one section, and I'm not going to. I'll talk about it later. It says, is this a perfect square trinomial? It did. If it said, is this a perfect square trinomial? It would not be because of this right here. 6 is not a perfect square. You get that, right? Now, is it factorable? Yes, because two numbers that make up 6 are 2 and 3, and they conveniently add to 5. You see what I'm saying? So is this the perfect square trinomial? No. Can you factor it anyway? Yes. Does everybody get that?
So would we have to make the parentheses?
So yeah, so the answer to this would be 6, and then you would say x plus 2 or 3, it doesn't matter. And then x plus the other one, whichever other, this part wouldn't matter the order. And that would be your answer if you were asked to factor that. But if they asked you, was that a perfect square trinomial? The answer would be no, because 6 isn't a perfect square. Okay? All right. So I just wanted to tell you that. All right. So the other ones I'm going to give you are perfect square trinomials. So let me change it back to this page where it has the stuff on it. Page 543. You're going to do 15 through 18. Now, guys, listen, this is 15 through 18 is mainly what we did today. All right. And then 20 through 31 is just a free-for-all. It's going to be like it is on the test. They're all mixed up. Okay? Also, just so you know, guys, we are going to practice the free-for-all Monday as well. So try not to, get really frustrated, because that's not helpful for you. And, of course, I'll be there for you. All right. Go ahead and get